So what about division in a different base? Well, it's by far and away the hardest because it involves multiplications, additions, and subtractions, and it's a head spinner for everybody everywhere. I've started with the same thing. I took the 506 in base 7. Notice on my division I put base 7 as a big sign, but I don't put the little 7s down in here in the problem. It just messes me up. You can put them there if you want, but I just prefer to have it a little cleaner. And so I wrote the 506, I expanded it out, I got 251. I can come over here, and on a good day I can do a division, and so it looks like we're getting 83 with a remainder of 2 is what it looks like. So half of the problem's done. Notice this about division. You can all do this half of the division, because you can learn how to do this, and your calculator does most of the heavy lifting, and you could even use your calculator to help you do this division in base 10, and so you can do half of this problem. That means of the 4 problems on the exam, they're not necessarily problems 1, 2, 3, and 4, but of the 4 problems that have an A and a B part, that's 8 total problems. That means one of them's addition, A and B, one of them's subtraction, A and B, one of them's multiplication, A and B, one of them's going to be division. This is hard, but this you can do. So most people can practice until they can do 7 out of the 8. The question is, can you do 8 out of the 8? Can we do this in base 7? And it turns out that it's probably best to do some multiples of whatever this number is. If you're dividing by 3, this is 3 in base 7. This is 3 plus 3 in base 7, or 3 times 2 in base 7. In base 7, this is 3 times 3. Why is that? Because in base 7, if you have a 1, 2, that's 9. 3 times 3 is 9, but that's a 1, 2 in base 7. Let me get rid of that circled thing. And so on and so forth. This kind of table really helps when you're doing division. For most people, it's the best way to do division. So 3 goes into 5 one time. That we didn't really need a table for. 1 times 3 is 3. We're feeling pretty good right now. But now starts the problems. You might be tempted to think 3 goes into there 6 times, and that's 18, but that's base 10 thinking. How many times does 3 go into 2, 0? Well, look, if you choose 5 times, that's a 2, 1. So you got to choose 4 times. And what is 4 times 3? Well, 4 times 3 is 1, 5. These are the multiplications by 3. 1 times 3, 2 times 3, 3 times 3, 4 times 3. So you got a 1, 5, but this is vicious. This is not a 20 take away a 15 being 5. Everything we write down on part A, everything is in base 7. So this 2, 0 is in base 7. That means down here it's a 2 and a 0. That's 14. And this 1, 5 is in base 7. So that 1, 5, that's 1, 7, and 5 1s. That's 12. So this 2, 0 take away 15 is really 14 take away 12, and that's 2. And that's a lot of work. And it's really easy, if you haven't practiced this, to get it all confused in your head. You need to practice these problems enough to where it doesn't get all confused in your head. You bring down the 6. Well, now 3 times 6 was a 2, 4, so we're definitely going to need a 6 here. And 6 times 3 is 2, 4. And 6 take away 4, happily we can do that. So I think we're getting this. Notice the remainders match. 2 is 2, and 3 is 3. And we did this on our calculator. The only question is, does 1, 4, 6 give us 8, 3? So 1 times 7 to the second plus 4 times 7 to the first plus 6 times 7 to the 0. I'm going to do that on my calculator here, and it does equal 83. So this number equals this one. That means these two match. That means we've done good work and we're getting full credit on a tough problem. So here in part A, I'm doing the division in base 8. I've already taken 200 and written it in base 10 as 128. And then I just went ahead and did that division, so I got 42 remainder 2. Before I can start doing part A in base 8, I need to complete this table. These are the multiples of my divisor. 1 times 3 and 2 times 3 is easy, but 3 times 3 is 9, and that will be 1, 1, because that's an 8 plus a 1, and that's a 9. 4 times 3 is 12, but that'll be a 1, 4. 8 plus 4 is 12. 5 times 3 is 15, but that'll be a 1, 7. Notice you're sort of adding 3 each time because they're multiples of 3. But now there's going to be a reset. 6 times 3 is 18. That'll be 2 8s plus 2 1s. And 7 times 3 is 21. That'll be 2 8s and 5 1s. So these are the numbers we're going to use. Now, 3 doesn't go into 2, so there's nothing above the 2. 3 goes into 2 0 this many times because 2 2 is too big. So we're going to get a 17 there. 3 times what gives us that? I called it a 17, a 1 7. 3 times what gives us a 1 7? Well, it's 5 times 3. Now this 2 0, take away 1 7, that's tricky business. That's a base 8 kind of thing, and so this is 2 8s, that's 16. This is 1 8 plus 1 7, that's 15. So these two, when you subtract them, it's just a 1. That's pretty weird. That takes some effort. Bring down the 0. It looks like this is going to go in twice. 2 times 3 is 6. This is 8, take away 6, that's 2. Remainder 2. 5 times 8 plus 2 times, I'll call it 8 to the first. This gives us 40 plus 2, and that is 42, and that checks. What about problem 53? Well, as always, I translated it into base 10 to 2 part B first. 4 of these 7 to the seconds, 0 of the 7 to the firsts, and 4 of these 1s. And when I did that on the calculator, I got 200. I came over here and did the division in base 10. The reason I'm doing this consistently in this order is to show you that if you're getting discouraged about all this, you can at least do half the problem pretty well. Not everybody, but almost everybody can train themselves to see what's going on and get that far. By far the hardest thing to understand in this section is what happens in this kind of situation. And the key is to make yourself a little fraction of a multiplication table. This is in base 7, but it's the multiples of 6. 1 times 6, 2 times 6, 3 times 6. Well, 1 times 6 is 6. That's not a problem. But 2 times 6 is 12. That'd be 1 of these and 5 of these, and that's a little bit of a problem. 3 times 6 is 18. That'd be 2 of these and 4 of these. That's a little bit of a problem. 4 times 6 is 24. That would be 3 of these and 3 of these. Now, I don't know if you notice a pattern here. This 6 is really a 6, but I'm going to think of it as a 0, 6. Do you see a pattern here? It kind of looks like the first digits are going up 1 and the last digits are going down 1. So I'm going to be guessing that this is what we have. So let's just check out 6 times 6. 6 times 6 is 36. Is that 5 7s plus 1 1? You bet. So that's kind of interesting little pattern, but it's probably not worth very much. Now 6 doesn't go into 4, but 6 goes into 4 0. This is the key row. 4 6s gives you 3 3 in base 7. So 4 6s gives you 3 3. Now you've got to do that subtraction. And we could do it in base 7. We could change it all around and borrow 1 and do all that kind of stuff. But that gets this pretty messed up. People can do it. You can do it if you want. But I like to just transfer this over, this little subtraction over to base 10. So a 4 0 would be 4 7s. That's 28. A 3 3 would be 21 plus 3. That's 24. When we subtract, we get 4. So this is a 4. Bring down the 4. This becomes the key row. 5 of these 6s will give us a 4 2. And there is a remainder of 2. It's really heartening that the remainders match. Then the question is, does 4 5 in base 7 give us 33? 4 times 7 plus 5 times 1. 28 plus 5 is 33. It checks. We're done. Good work. You should practice these. One way to do it is to wait a little bit and then do these problems on your own, without notes, without looking at these notes, to see if you remember how. See if you can do it. Practice these problems a few times. Practice some other problems from the book. If you have software, you could find software practice problems. If you don't, you can make up your own problems. But know this, all 8 of these, the addition problem A and B, the subtraction problem A and B, the multiplication problem A and B, and the division problem A and B, all of them are in base 6 on your exam. Every single problem is base 6, so get familiar with base 6. And a lot of the problems have the same numbers. So for instance, I don't remember what the problems were, but what if this was one of them? I don't know that this was one of them. That wouldn't have been one of the problems, but say it was. Then the part A would be to do the addition in base 6, and part B would be to turn it into base 10 and do the addition in base 10 and see if it matches. But what I'm telling you is then that the subtraction problem on the exam will probably look like that. In other words, it would use the same 2 numbers often, but you would have to subtract them, and that helps you save some time. Because then when you turn them over to base 10, these are the same numbers. So think about this as you're practicing, and good luck.